For an overview of the three CNS domains, let's start with the communication domain. Radio, the voice communication between pilot and air traffic controller. For the air traffic controller to communicate with the pilot, Skyguide has installed radio antennas all over Switzerland, including an emergency backup radio communication system. This is the most important means of communication here. Controller-pilot data link communication, CPDLC, is a digital way of exchanging messages, eliminating crosstalk and acoustic understanding issues. The messages or instructions are received in text. This is being used more and more. In addition to the radio communication between air traffic controller, pilot and the data link service, the communication domain deals with the following vital systems. Telephony systems are essential for the coordination with adjacent control centers and partners. Different voice communication systems link the controller working positions with the radio sites and the phone network. Broadcasting systems continuously distribute environmental information, such as weather or runway status, to all aircraft. Finally, we have the legal obligation to record all the communication in order to have the possibility to investigate in case of issues or problems. Next, let's look at the navigation domain. Distance measuring equipment, DME, showing the distance of the aircraft to the DME. The distance measuring equipment, DME, shows the pilot how far the airplane is from that navigation aid. Skyguide has many DMEs installed all over Switzerland. The instrument landing system, ILS, uses electromagnetic beams leading the aircraft to the beginning of the landing runway in any visibility, like in clouds or fog. Skyguide has installed ILSs at every major airport in Switzerland. VHF omnidirectional range, VOR. Pilots can see in which angle, bearing, they are relative to the VOR. The VHF omnidirectional range, VOR, is a navigation aid on the ground which lets the pilot determine his angle towards that VOR. This technology has been used for decades to enable pilots to fly procedures or find their position while in bad weather or in clouds with low visibility. Skyguide has several VORs installed throughout Switzerland. Finally, an overview of the surveillance domain. Radar, detecting the location of airplanes for air traffic control. A radar is an electronic system determining the distance of and direction to aircraft around it. This allows the air traffic controller to observe the air traffic on an electronic map. Skyguide operates different types of radars for purposes like monitoring the approaching traffic, identification, and tracking en route traffic, as well as observing ground movements on the airport. Automatic Dependent Surveillance Broadcast, ADSB. The position is automatically sent from the aircraft to ground stations and surrounding aircraft. Automatic Dependent Surveillance Broadcast, ADSB, is a surveillance technology where aircraft broadcast their identity, position, and other information. Pilots and air traffic controllers get an overview of the traffic in the air, which is dependent on the aircraft's own information. An ADSB network consists of many small antennas over a large area. Multilateration, MLAT. The aircraft can be located with an array of small ground stations. Multilateration, MLAT, is a technology to calculate the position of aircraft based on time difference of arrival of emitted signals. Signals transmitted from aircraft or ground vehicles are being used for this. Skyguide owns and operates these systems in Switzerland. They need to be checked regularly for accuracy and correct function, and they need to be renewed regularly with a lifetime of around 15 years, depending on the type. Skyguide installs, maintains and replaces this equipment at the airports and all over Switzerland to ensure a safe flight under any conditions.